Welcome to the A2 video in which we will discuss the slope of a line. Okay, so slope is a word you'll be hearing a lot throughout A2 and actually throughout the rest of Algebra 1. So the slope of a line refers to the angle a line is at in the coordinate plane. It can be found in different ways depending on the information given, and we'll discuss all the scenarios. So if we're given a graphed line, just like this down here, okay, the slope can be found by finding the difference between two y-coordinates and dividing it by the difference between two x-coordinates. Okay, and this method is also called the rise over run. Okay, so if we're taking a look at the rise here, I'm going to pick 2 points. In this case, they were already picked for me. So I'm going to take a look at the difference in the rise here. Okay, so from this point to this point, our rise is 1, 2, 3, 4. So I'm going to put a 4 right here. So what is the rise? It's 4. Now what is the run? What is the difference between these two x-coordinates? Well, the run is just 1. It goes over to the right 1 unit. So my run is 1 unit. So rise over run, that's how we find the slope. So as I just pointed out, my rise is 4 and my run is 1. So 4 divided by 1 is just 4. So 4 is my slope for this line. Okay, pause the video if you need more time. Okay, now we'll take a look if we're given an equation in slope-intercept form. So slope-intercept form is y equals mx plus b, where b tells us what our y-intercept is without even doing anything. No math involved at all. And m tells us what our slope is. Okay, so if we're given an equation in slope-intercept form, we don't even have to do any math. All we have to do is look at what number is being multiplied by our x. Okay, so as I just said, if an equation is in slope-intercept form, all we need to do is identify what the m is. Okay, so right here, I'll write it again, y equals mx plus b. So there's my y, there's my x, there's my b. So this negative 1 over 3 must be my m. So the slope is negative 1 over 3. I can't reduce negative 1 over 3, so I'll just leave it like that. Okay, pause the video if you need more time. Okay, now we have an equation in point slope form. So point slope form is y minus y1 equals m times x minus x1. So this is called point slope form because we're automatically given our slope, and we're also automatically given a point. Okay, so this would be a y coordinate, this would be my x coordinate. Okay, so if an equation is in point-slope form, all we need to do is identify m by looking at the number outside of the parentheses. Okay, so I'll rewrite the equation. Y minus y1 equals m times x minus x1. And I strongly encourage you to, if you are given any type of practice or assessment, I would write my 3 linear equation forms right at the top of the paper, right next to where you write your name. That way you can refer back to them at all times. So we have y, we have our y coordinate, we have our m, we have our x, and we have our x coordinate. So again, just like the slope-intercept form equation, I'm just trying to find what m is. And as I said right here, it is the number outside of the parentheses. So I've got a -4 outside of the parentheses, so my slope is -4. That easy. Okay, pause the video if you need more time. Okay, let's say we're given an equation in standard form. So there are 2 ways we can find the slope of an equation given in standard form. We can either solve for y, which would get the equation in slope-intercept form, which is personally how I learned to find the slope of an equation given in standard form. Or we can use something called the Jakes method, which I realized is a strategy that Mr. Jakes learned how to do. So we'll call it the Jakes method for right now. So let's do it both ways. So let's solve for y. We'll switch it to slope-intercept form. So if I'm going to solve for y, my first step, I would subtract 6x. Okay, 6x's cancel. I'm left with -5y equals -6x plus 25. Okay, so to get y by itself, I need to divide by -5 on this side. I also need to divide both of these by -5. Everything is being divided by -5. So when I do that, -5's cancel, so I'm left with y equals -6 divided by -5. Well, the negative signs can cancel out, so I'm left with 6/5 times x, and 25 divided by -5, which is -5. So this is in slope-intercept form because the y is by itself. So as we just discussed, if I'm given an equation in slope-intercept form, I'm just trying to identify what my m is, so what number is being multiplied by x. So in this case, it's 6/5. So the slope equals 6/5. And that fraction can't be reduced, so I'll just leave it like that. Okay, pause the video if you need more time. Okay, now let's do the Jake's method. So, this method requires no, use the word manipulation of the equation. So that means I don't have to really do a whole lot of math. I'm not moving things around in this equation. I'm going to leave everything as is. So it turns out we can find the slope by taking our general standard form equation, which is ax plus by equals c, where x and y are on the same side, and finding what negative a is and dividing by b. Okay, so if I do that, I know this is my a. And again, we're taking a look at the same exact example as we did above. So I know the slope is 6 over 5. So let's see if we get the same answer. So I know this is a, this is b, and this is c. So negative a would just be negative 6 divided by b, which is negative 5. Actually, let me circle those. Okay, and just like above, our negative signs cancel, so we're left with 6 over 5 as our slope. So, does it matter which method you use when given a standard form equation? Absolutely not. You should get the same answer. Okay, pause the video if you need more time. Okay, so we're going to take a look at an example we've already seen before. So we already know that our slope for this line is 4. Okay, and we did that up above when we were given a graph. Okay, but what if we were just given the coordinates of the 2 points? So let's say we were given this one, which is 1, 2, and this point, which is 0, negative 2. Okay? As we have discussed, we know if we were given a graph, the rise over the run gives us our slope. So if we find the difference between these 2 points, the y coordinates, let's say, that would give us our rise. So I'll write y2 minus y1. If that doesn't make sense to you right now, we'll discuss it in a second. And if we divide it by the difference of our x coordinates, so x2 minus x1, we would get our slope. So we have our rise over our run. So what I'm going to do is I'm going to label these points, all 4 of these, okay? So it really doesn't matter which x you pick to be x1 or x2 or which y you pick to be y1 or y2, as long as you're consistent, as long as you pick one point to be your 1 and one point to be your 2's. So let's say we have this x as x1, this x as x2, which makes this y y2 and this y y1. Okay, so if we find the difference, so y2 minus y1, and divide by the difference of our x coordinates, so x2 minus x1, we would get our slope. So I'm just going to plug in these points. So y2 is negative 2 minus y1, which is 2, divided by x2, which is 0, and x1, which is 1. So minus 1. So if I do a little mental math, Negative 2 minus 2 is negative 4. 0 minus 1 is negative 1. Negative 4 divided by negative 1, well, we know that's 4. So that would be our slope. So at this point, you can either move on to the A2 slope practice, A, B, or C, or if you want to watch me do a few more examples here, the next video you can watch is called Examples A2 Slope video. Okay, so give that a watch for a couple more examples.